You are now muted.
data. So we will begin with a bit of a primer on big data, the implications of it, where all of these big data sources come from, who should be worried about it, and then we'll jump into a Q&A type session with Frank, who can give us expert comments about his take on big data, the trends affecting the marketplace, and how does it apply to you, and how do you monetize it in your environment. And then we will conclude. We will take some questions from the audience. Please use the live chat window and send us some questions, which we will address towards the end of the webinar. So to begin with, and give you a context of big data, that's a term that's been thrown about quite a bit in the past year or two. There is some significant technology as well as business advancements in the area of big data, and not to mention a significantly high amount of spend by companies in wrestling big data as well as understanding it. And according to IDC and Gartner, there's a tremendous amount of investments happening now, and that will continue to happen over the next 5 years. There's a lot of variation in these reports, but the point of it being there's a tremendous amount of growth of important data coming from various sources, and a terrific amount of investments and technology innovations that are happening in helping people understand this big data, and with the specific notion of being able to monetize it, create new business opportunities with it, identify new revenue streams with it, etc. So it's not just about managing big data from a flow and storage standpoint, but more importantly, how do you deliver insights from all of this big data? That's what this market is really all about. Now, if you look at some hot new trends affecting us, what's been going on over the last couple of years, and we at Cetas have talked to hundreds of customers and engaged with them deeply to understand what's impacting their environments. One of the foremost things that is on people's minds is Hadoop. Hadoop is extremely powerful technology and has been around for a couple of years. It's important to understand that Hadoop is a technology, and you really need a lot of relevant skill sets to be able to leverage Hadoop for your benefits. Now, what Hadoop does in a nutshell is it helps you understand data. It helps you break down data. It helps you process the data. And there's some interesting paradigms associated with Hadoop, which I'm not about to go into in this webinar. But suffice it to know that it's extremely good technology, but also that it is just technology. There needs to be a business wrapper and an operational wrapper around it, because the skills of Hadoop are very special. Not everybody can run Hadoop in their environments, and it takes some special knowledge to be able to leverage it. The second big concept that I'd like to talk about is machine data growth. And this is key because there are several things in your infrastructure that require sending out of data. So think about it as sensors, think about it as your infrastructure components. Essentially, all of these comprise what is called machine data, and there's a significant amount of growth of machine data. And all of this data is key for you to leverage in order to gain insights from all of it. The third is about application platforms, and there's a terrific amount of growth in application development platforms with embedded analytics. These are platforms that people are leveraging to build applications on top of. So you don't have to go in and reinvent the wheel every time there is a new application that is created. These application platforms are able to give you embedded analytics that give you analytics out of the box. There's probably a certain amount of cap associated with these. We'll talk about that in the coming minutes. Mobile apps and devices, yet another trend, and we've seen this. This is not just the consumer space. There's a terrific amount of growth of mobile applications and devices, even within the enterprise. And these are enterprise applications. Think Salesforce.com. Think your Salesforce that is out there and communicating back with your core sales database. Think of marketing campaigns that are being run. Not all of these are being done within the enterprise on desktops and on servers. A lot of this is roaming data. And overall, from a deployment option standpoint, analytics as a service has become a pretty hot concept over the last year or so, where being able to deliver analytics as a service over a cloud infrastructure, whether it's a public cloud infrastructure or private, almost doesn't matter. It's the elasticity and the ability to run this as a service that's what matters. And overall, all of this is geared to give you analytics and insights to drive your business forward, because the ability to take an action based on all of this is key coming out of analytics. So let's take a quick look at some of the sources of data. The sources of data are many, and we've grouped them here for you. There's a good number of social media sources that are contributing to big data. Here are things where not only are consumers but also enterprise content placed. There are sentiments to be gained from some of these social media sites. There are social gaming sites. There's a terrific amount of activity happening on the social front, which leads to a lot of event data being created, billions of events in a single day by single apps. You're talking a whole lot more data that was created within the enterprise. On the top right, you see machine data, sensor data, infrastructure data, application data. These are coming in rapidly, and being able to derive some meaning out of it, apply certain trends and patterns and machine learning algorithms to determine what exactly is contained within this machine data, how often are a certain confluence of factors coming into play. Things like that are really important to understand benefits from trends and patterns, and being able to ultimately predict a certain outcome if a certain confluence of factors is seen. So it's very important to take that action on machine data. And on the bottom, you see applications and infrastructure components. All of these are sources of a large amount of big data. And again, the goal of wrestling down big data is not really just for the purposes of storing all of this information and managing it. It's really to derive insights out of all of this. So being able to apply fast-moving algorithms to understand trends and patterns contained within the data, to be able to apply algorithms to predictively tell you what's going to happen next, to be able to recommend certain things to you, to be able to understand customer behavior in detail, and being able to monetize that customer behavior. That's what understanding big data is all about. Many of you may have heard of the 4 V's, or the dimensions of big data. We won't talk about it too much, but just to touch upon what these dimensions are, there is the velocity with which the data comes in. Like I said before, there are companies generating billions of events of data through single applications in a single day. That's a terrific high rate of transmission of data. And all of these clickstream and other transactional data are important to be analyzed. It's hard to tell what to throw away and what not to. You have to be able to analyze them really quickly. So the ability to get all of this data, analyze it, and rapidly take the ones you need and derive the insights is important. That's the velocity dimension. The variety dimension is important as well, in that not all of your data is going to come in the same form and structure every single time. So you're going to have applications that send out certain kinds of event data today. Your application may change tomorrow. You may have a certain different format of data tomorrow, as well as you may have a different length of data, different fields contained within the data. And that's the beauty about good big data platforms, is you do not have to essentially conform to a specific schema and stick to it. You are able to change your application based on the needs of your customers on a daily basis, on an hourly basis. And yet the underlying platform doesn't have to be notified, ETL doesn't have to be performed. You're able to, in a schemaless fashion, run with big data and analytics. So that's the importance of variety. The third dimension is about volume, which we all know about. There is a huge amount of big data, enough said. And finally, it's the value. And this arguably is the most critical dimension of the lot, is what value is your big data analytics platform able to derive for you? What insights is it telling you? What is it giving you that is able to transform your business in an actionable way? We're not talking about reports that you get at the end of the month. We're really talking about intraday, intra-hour, if you need, value that is being fed automatically or interactively so you can make a decision on your application. That's really what it is about, is to derive value. The approach that we recommend, as well as have seen be extremely successful, is more value in software and in services, as in cloud-based delivery models. It's not about throwing big iron at the problem. It's not about having racks of servers or CPU power. It's not about that. It's really about the intelligence in the algorithms that is able to crunch through all of this data and derive insights for you. So the intelligence in the algorithms is what makes the difference. It's not the power of your servers or your racks or your the number of CPUs or RAM you have. They may all be important, but they are not the differentiators. That's not what gives you the insights. The algorithms are what give you the insights, to be able to tell you from a business or operational perspective what's happening, what are trends, what are the patterns, and how do you plan for this in the future, more importantly. So the takeaway here for us is it's about the intelligence of the algorithms and the software approach and the automatic elasticity that you can build into your environment. It's not about throwing iron at the problem. So there are two use cases, a slide on who should worry about big data, who are the personas involved from a buying as well as usage standpoint, after which I'm going to have Frank give us some of his comments about the big data trends that he's seeing and what he's covered in his new best-selling book. But before we get there, a couple of details on two very broad use cases for big data. One of which is what we call business analytics, or more specifically, online application analytics. Here we talk about applications that are transacting data and interacting with humans. And here it is all about customer behavioral analytics. Insights on the business end, from a revenue standpoint, from a user behavior standpoint, from an audience segmentation standpoint. And the goal of all of this is, how do I grow each one of these dimensions I just mentioned? How do I grow my customer base? How do I grow my engagement with customers? What about my loyalty? What about the revenue or the amount spent? Things like these are very, very important. How do I grow my business and identify new revenue opportunities? So collectively, we call this business analytics. The second use case is around IT and operational analytics, where we get a bit more prescriptive from an infrastructure or applications management standpoint. Here we talk about troubleshooting, about root cause analysis, about investigative analytics, where you are investigating something. You want to find the reasons for an outage or for degraded performance or for a denial of service attack, and how to prevent these in the future. How do you plan your environment such that anytime there's a confluence of certain things that happens, leads you to plan for an outage or a degraded performance period or something of the like, where you're able to apply the learnings of today towards tomorrow. So this we call IT and operational analytics, which is centered around investigations. A quick note about who should worry about big data and plan for big data. Who are the buyers of big data solutions and who are the users of it? We see them in three categories. The first one of which is more on the business analyst side, line of business managers, executives. These are people who are interested in certain business metrics or KPIs, key performance indicators. And they need to manage these, they need to monitor these, they need to make decisions based on these, and they need those now, not tomorrow, not next week, and not at the end of the month. Much of these are online businesses, fast-moving businesses. They need to know now what is going on in their business so they can take some action right away. The second category is what we call power users, data engineers, data analysts, and sometimes, in some cases, data scientists. And these are folks who want to play with the data. They mine the data. They model the data. And they want to get very, very deep into interactions and correlations and trends and patterns and mathematical and other modeling. These are people who know play with the data. These are what we call power users, and they are an essential user of products in the big data space. And finally, we have operations buyers and users. Here we are talking about administrators, we are talking about IT folks who are interested in investigative and troubleshooting type analytics. So with that being the background, we covered different dimensions of big data, popular use cases, which are either business or on the IT and operational side. Who should care about this? And now I'd like to kind of get Frank to share some of his insights from a non-vendor perspective. Frank, again, welcome to the webinar.
Thank you.
I'd like to ask you at the very broad level. You've written a good best-selling book. What is, in your mind, big data? Do all of these dimensions that I talked about gel with the real world? Give us your take.
Oh, yes, definitely. I mean, you touched on all the elements that make up big data. But, the one thing I want to point out here is that big data is a horrible term to use for what we're actually talking about. I mean, the original definition of the term big data comes from data sets that are too large to handle with normal or, traditional technologies. Now that, Hadoop and other technologies are readily available, they're moving into the realm of traditional technologies. So, we really should call it something different than big data. We maybe large-scale analytics or multidiscipline analytics or something along those lines. No one has coined a really good term for it yet, but, I just want to point out to folks that term big data has a lot more meaning to it than what those two words indicate. And, and it actually goes back for some time. I mean, you can kind of link the arrival of big data back to when analytics came into vogue, especially in the enterprise world. Now, if you look at it from, the scientific and medical world, big data has been around for a very long time for people to analyze all sorts of information that's generated by either testing or hypotheses or, even things such as, particle accelerators where you have to delve through gigabytes, if not terabytes of information to find out what's going on. Now, using that ideology of looking at these very large data sets, businesses can turn to that same ideology to look at their very large data sets. All that information that they tend to have to archive that's normally a liability. Why not take that liability and turn it into something positive? Now, you covered many of the different cases out there where, that analytics can be applicable, but it's more than just that. It's the pairing of those data sets to look at relationships. And therein lies the intrinsic value, how that you are able to take those large data sets, build these relationships, and develop algorithms to reveal that information to answer a business question, which means, you have to know what the questions are to ask.
Frank, I think the last part of what you said completely echo that. Couldn't agree more. In fact, one of the things we often say in our customer engagements is, if you knew all the right questions to ask, the problem is much, much easier. And the value of this whole thing really is in the fact that we frequently don't know what the questions to ask are, and therein lie those unsurfaced elements that if we could really figure out what they were, we could figure out new revenue streams and new opportunities. So the takeaway from what you said to me is, if we can have our technologies work for us to uncover trends and relationships and patterns that we didn't know to query, therein lies the value. And I kind of agree with your over-usage of the term big data. I like the tagline of your book. Maybe we call it big money, Frank. No more big data.
I kind of like that ideology too, but that really lends itself to kind of the whole commercialism and capitalism around data. But then again, in the business world, that's what's important.
Yes, exactly. So we'll jump into the next big topic, and we kind of started talking about this. Why does this whole thing matter? I mean, haven't people dealt with big data before? Why is this all of a sudden new, and why is everybody talking about it? I have a certain take on it, but we really would want to hear your take on this first.
Well, I think there's many things have changed in recent years, especially with how we deal with data. I mean, there's all different types of data now. I mean, if we reach back into the past, it was all, basically structured SQL type data, logs and things like that. Now we're moving into the realm of, unstructured data and other types of data, whether it's, stored video, stored audio, unstructured databases that deal with online real-time transactions. Data is evolving in such a way that what we used to call data is no longer applicable. There's just so much more depth to the data that's available. Now that, complicates things. The way that you apply analytics to, log files changes dramatically if you're looking at video and audio. Let's say you have a VoIP system in your enterprise and you want to mine that data, those phone calls, to look for certain terms and elements like that to perhaps, judge customer sentiment during a tech support call or things like that. It's a very different analytical path that you have to follow to reach into that. Now, once you're able to reach into that and expose the information that you need, you can then correlate it to your other types of data. Whether that data becomes, how active your network is, or how many orders were processed in a given time on a website, or, the list goes on. Mm-hmm. But the point is that it's these hidden relationships that you can expose between an event and the data surrounding it that can deliver all sorts of insight. Now, we've kind of seen big data in use for a while. For example, if you take a look at Amazon's web page, when you go to order something, when you're looking at a product up there, all of these recommendations come up about other products you may be interested in, or what other folks who have looked at this product have also bought. That really relies on the machinations behind big data and the whole analytics ability wrapped around big data. Another area where you can kind of look at big data being applied in a realistic fashion is just with Google searches, where you look at behind the scenes, the algorithms that are used to mine through all that collected data to come up with relevant search results. Again, that kind of fits into the ideology of big data. And then if you look at Google searches, it even goes one step further. There, you can now search through video. You can search through all different types of content based upon keywords, something that was thought to have been kind of impossible in the past. Mm-hmm. So I mean, although there are still all sorts of obstacles that remain, none of them are insurmountable. What it really comes down to is the knowledge on how to deal with that data, how to deal with it, whether it's structured or unstructured, and how to write and create the algorithms around it to be able to mine your big data source. It used to be that the challenge behind big data was the amount of storage space needed. Hadoop and other technologies have kind of solved that problem. Also, the other problem that we used to encounter with large-scale analytics was the time it took things. Again, Hadoop and in-memory processing and elements like that have solved those problems as well. So, those obstacles are out of the way. It's how we deal with the data and how the data continues to evolve that's really going to impact what we do in the future.
Yep. So a couple of things that I'll repeat from what you said, Frank. One, the data that is being generated these days is quite different from, say, even 5 years ago or even 3 years ago. And I'll throw a couple of the examples that I've come across. For instance, if you think about the online advertising industry, there's a terrific amount of investments that has gone into learning customers' behavior and click patterns, and a whole new market called retargeting, audience retargeting, has emerged very recently. And that's all about knowing where you've been before so we can present targeted offers to you to maximize your click-through and your conversion and the yield, therefore. So that's a pretty new market that has been enabled due to the advancement in technology and the algorithms that are able to correlate your buying patterns with your desires and where you've been in the past and all of that, together coming up with richer yielding results. And another example.
Right. That really comes down to empowering other technologies such as breadcrumbs and cookies. And it's interesting how you can apply that big data methodology to something that was thought as so inconsequential as a cookie.
Yeah, exactly. And to touch upon another example that you mentioned about Amazon, who arguably are the leaders in recommendations. My colleague recently presented along with eBay at a meetup a couple of months ago, and the joint presentation was about recommendations. eBay's got a massive investment going on in that, but one of the observations they made themselves was even up to about a year and a half ago, according to them, their recommendations were simplistic, keyword-based. For example, if you bought a phone, it would recommend other phones to you. But obviously, once you've bought a phone, why do you need 5 other phone recommendations? Rather, they had to fine-tune the recommendation engine based on who the customer was, what sort of a phone they bought, other details and browsing patterns that led you to conclude that perhaps a choice of headsets or noise-canceling phones if they are prone to traveling, things like that were more, obviously more attractive as a secondary buy as opposed to a bunch of other phones, which would be the more simplistic keyword-based recommendations, which obviously are not as appropriate. So it helps to kind of know who the buyer is so you can make the right recommendations to them. So moving on, this here is an important topic, Frank. How do you build the right big data team? So if you are, say, a LinkedIn or a Facebook, obviously you have the luxury of having technologists in your staff and therefore maybe a team of data scientists. But if you're a gaming company or an advertising company or an e-commerce or maybe a smaller company, you may or may not have the luxury of building teams. So what does the constituency of a big data team really mean, and who needs it?
Well, here is one of probably the biggest challenges when it comes to leveraging big data, especially for companies with limited resources. You look at small enterprises or even small business, and you run into the situation where you have limited resources. And, when you take a look at the requirements to effectively use big data, you need a very high level skill set, and you need people that understand the intricacies of data and know how to understand and reveal relationships between the data, and then also how to mine that data, which kind of brings us to a term which I use kind of loosely, which is called the data scientist. And at this point in time, a data scientist is someone who has expertise in dealing with large data sets and creating the algorithms to mine those data sets. It is currently a relatively unique skill set, and it's in high demand. There are businesses all over the place that are looking for the caliber of person that can be a data scientist. However, that's starting to change. As the technology matures, more automation is coming into play. More automation means more, wizard-based type capabilities, canned solutions, handheld type solutions similar to Wizards, reduced learning curves, and everything like that, which might make someone like the data scientist less critical in an organization. But it kind of shifts the burden over to someone with project management skills. So it's not like we're going to be able to eliminate a certain level of expertise in management to be able and still pursue big data. Now, the reason why a product management skill set comes into effect is that normally to really understand what's going on in an enterprise and to leverage that massive store of data, you have to put a team together. And the reason why you have to put a team together is that there's not a single individual that can understand every aspect of the business. It's very limited when it comes to resources for someone to know everything about the business. So when you put a team together, you have to kind of include folks that have some marketing savvy. You have to have some folks that have customer experience savvy, folks that understand the accounting cycle. And you kind of have to pick and choose these folks because these are the people that are going to help you ask the right questions of big data. Mm-hmm. And in many cases, smaller businesses, just don't have the resources to do that. So they wind up having to turn to external sources, consultants or services to help them with that. And that, of course, does add another kind of layer, a middleman layer, and, can add some different type of complexity to the team challenge while eliminating some of the other concerns. So it really comes down to, a business ideology, how you want to implement the team, how you want the team to be run, and then you have to decide what the real goals of the team are, and if you need to have different teams to address different goals. Again, that all comes down to scalability. And, finally, you can't forget about the data. You have to take into account the type of data that you're looking in, the future types of data that you're going to be looking at, whether it's structured or unstructured, whether it's public data or internal data, and also what security requirements are around that data. For example, a hospital or a medical practice is bound by compliance laws. So if you're going to turn your data over to an external source, you have to kind of look at what the security implications are there. So, these are all the things that you have to consider when you're putting together a team to dig through the data. On the flip side, you do have the simple alternative of outsourcing the whole project. But when you outsource, you give up some of the control, and it's a little bit harder to direct what the results are going to be.
Right. Agreed, Frank. One thing I'll add from my observations on this is we've seen a number of companies, especially the smaller to mid-sized ones, in some industries, even the larger ones, they have significant do-it-yourself approaches to handling analytics for big data. And the one observation that I've made from all of these, or at least most of these, is beyond a point, to your point about scalability and the depth of algorithms, they are no longer able to rely on the do-it-yourself methods, which are a great experiment and they work. But once you've proven it out that certain technologies can work, you really need expertise, not necessarily in the form of people all the time, but maybe analytics as a service, where algorithms that are able to scale and perform and go deep is what you ultimately need. Do-it-yourselves are really not economical, let me put it that way, from a skill standpoint, from a time it takes standpoint, etc.
Right, but in another respect, the do-it-yourself out there works well kind of for the pilot project ideology, just to educate a business on what skill sets they don't have that they need to seek out. So the best way to uncover what you lack in capability is to try and do it yourself.
Exactly. Completely agree with that. So let's move on to the next topic. I touched upon it very briefly earlier on, big data sources. There's a tremendous number of sources from which you get data. There's machine data proliferation. There are applications that are generating a ton of clickstream activity data. There are, of course, all of the social media sources. Now, is there, Frank, a good or important data source, or are they all the same? How do you view the sources?
It really depends on what questions you're trying to ask of the data. And I'll give you an example. If you're using big data analytics to judge things like traffic patterns, at a municipal level, you're going to be gathering data from your sensors out there that kind of tell you what's going on. You're also going to be gathering data from certain elements such as your street lights, your street signals, traffic measuring sensors. You might want to also gather data from toll booths. The list goes on, these different type of data resources that you have to reach into to be able to leverage the information to understand what's going on. But beyond that, that seems all straightforward, but there's another element that you might want to include, and this is where you start looking for external data. You might want to take into account, number of registered vehicles in the area. You might want to take into account economic concerns, what the unemployment rate is sitting at. You might want to take into account weather patterns and concerns. You might want to take into account shopping history, what large retail establishments are doing in sales, looking at economic data. So it really comes down to the quest for the data, the hunt for the data. And in most cases, more is always better than less, because the idea is that the more insight that you can put into your equations, the better tuned your answers are going to be. So that comes into the fact of the point where you want to set your goal. You kind of have to have an idea of what you want to get out of this data. You kind of have to have the initial question that you want to ask. And coming up with that initial question can sometimes be a challenge. And but the good point of it is that once you come up with that initial question, that generates all of your other questions as you delve deeper into the data. It helps you to develop that metrics. Now, on the plus side, your data sources are growing. There's more and more data being made, more readily available all over the place. Some of it for free, whether it's federal type census data or weather data or some of the economic data. Some of it you have to pay for. Some of it is based upon social networking, which becomes a very good source for gathering customer sentiment information. And the idea here is that you need to dive deeper into those sources to really determine what is relevant. But also you have to be careful not to dismiss certain data points as well, because although you might not see the relationship initially, there may be a relationship that can be derived by bringing in other data sources. So it really kind of is almost a free-for-all when it comes to finding what data sources you want to use. The key is to identify what you want to get out of the data, what questions you want to ask, and then look for the sources that are going to feed into those questions.
Very good. So I think we touched upon some of this before. Big data is not entirely a new concept. It's existed before, but there are certainly some things that are different. So specifically about the algorithms, what's your opinion and belief around algorithms, the importance of those?
Well, when it comes to the algorithms that are used to search things out, they have to be treated as living entities, things that can evolve. Because each time you ask a question, depending upon the data that you have behind it, you might get a different answer out of an algorithm. So the algorithms have to evolve to understand your data sources. And algorithms are becoming ever more complex for that reason. So we're starting to see a lot more automation coming into play for developing the algorithms, something that assists, those developing the algorithms to be able to almost ask questions in plain English, and the automation converts that into the mining technology to pull the information out. The other issue that we're running into is that, as this data evolves and the type of data that we have to make sure that we're asking the right questions. And the best way to kind of explain that is kind of with an example. Many years ago, there was a correlation created between ice cream and polio. It's because, the federal government did research, and they discovered that, in the 50s, the early 50s, and in the 40s, that polio seemed to be on the rise during the summer months when ice cream was consumed a lot more. Now, the funny thing about it, there was really no correlation between the two. It was just that the data that they used to determine that didn't show the whole picture. The real reason that they came back with that, why the incidence of polio increased at that point in time, was because of more personal contact in the warmer weather and the lack of cold weather to help kill off viruses and elements like that. So, that's kind of where that comes from. So the key here is to make sure that you're taking into account the big picture and that you're making sure the algorithms are looking at the right data sets.
Yep. And I'll say a thing or two about the algorithms as well, Frank. I agree with observations such as the one that you just mentioned about polio and ice cream can be misleading. So the effectiveness of algorithms, or to be more specific, machine learning algorithms, lies in, by definition, how much they are fed and therefore can learn. So the more data that is being fed through these algorithms and the more they continue to learn is going to be key. And at the same time, business owners, operational or on the business side, have to have influence in the results of these algorithms and constantly tune them too, because you can assign different weights to different factors such that the confluence of factors doesn't always add up equally. You could have a certain dimension be of more value than another dimension, and therefore it skews the result or the predictive nature of these algorithms. And that sort of influence to customize everything is important in running your business. It's not a one-size-fits-all approach. The power of these algorithms with the power of analysts molding them is key for success.
Yes,
so,
very much so.
So best practices, in your opinion, and advice, how would you, recommend to companies when they are starting off or when they are in their early stages of, wrestling down big data challenges? Where should people start, and what's the best practice, if you will?
Yeah, it's funny. It's almost ironic. I tell people to start small with big data. And by starting small, I don't mean with a small data set. I mean with a more simple type question. Uncover something of value out of your data set. Look at something like seasonal sales and how they relate to, economic factors, or something along those lines, with an idea to get kind of a simple answer out of the system that kind of backs what they might already know. The idea there is that it proves that big data will be able to deliver information down the road about things that they don't already know and be able to help them validate assumptions. The other reason why I tell folks to start small with it is that with a big data project, it's very easy to become overwhelmed. If you try and boil the water in all the oceans at once, you're not going to get anything successful out of it, and it's going to kind of turn the project into a major failure. Also, with the technologies that are available out there, whether it's elements like Hadoop and things like that, there's a robust open source market that allows you to kind of play with it, to kind of get an ideology and put together kind of a pilot project to figure out where you need to go when you start thinking big. Now, the other idea here is you've got to avoid the worst practices, and I have those outlined in my book. But the whole idea that big data can be done organically, no, it kind of needs to be managed and it kind of needs to be directed. And there's several other things. And the other element is to kind of take those baby steps. Don't rush into it. Come up with some clear set basic goals, and then pursue a plan that meets those goals and sets you up for the bigger picture. Did I lose you?
Frank, I think we are hitting the top of the hour, so I want to conclude with a couple of questions that we got. One of which was interesting. It was from someone who's interested in telco type of use case. The nature of the question, and this is not verbatim, but the nature of the question is, when you have a good number of unstructured data sources, how do you begin? And I can take this one. I think it's more of a technology question. The way I think about it, and telco or other environments, even in telcos, the CDR data has some amount of structure in it. But consider machine data, a good number of unstructured data sources. I think this is where the power of the platform comes into play in being able to auto-discover dimensions within the data and being able to present that to the business or operational owner of the data, so that they can either take what's already been parsed and processed and presented to them, or be able to modify some of this and teach the platform that this dimension really means this, or change the name of it, or apply even custom functions or measures on incoming data, in-event data, so you get the results you want. So the key is, in real time, being able to stream all of this, translate it, present it, and also allow the end user to make custom changes to it on the fly in a self-service fashion. I think that's where success is. So then even unstructured data sources become very, very structured and can follow the same format going forward. So I don't think this is, even though the question came from someone who's interested from a telco standpoint, I think even beyond telco, in other areas too, there's a good number of machine data and other sources which don't have to always be defined beforehand. The power of the platform should be able to make those interpretations and present them in a way that is consumable and customizable. One other question, and this, Frank, may be up your alley, and I have a couple of thoughts on it too, was both you and I mentioned it during various parts of the presentation. From a deployment standpoint, are we talking about these technologies needing to be in the form of hardware presented inside of an enterprise as an on-premise, or can they be cloud solutions? What have you seen, and what is your take, Frank?
There are many options out there, and it really comes down to what an organization has in CapEx versus OpEx for when it comes to investing in big data. Now, kind of in the past, as big data was starting to garner interest out there, what you would see happen in an enterprise is they would take systems that normally, that they would retire or that they'd replace, old servers, things like that, and build a Hadoop cluster with that old equipment to be able to start playing with big data. Now, in theory, that can work, and it all depends upon how much resources that you can throw at those systems. And the idea is that you're able to parse your data across this Hadoop cluster to start working with big data. But very quickly, businesses would start asking more and more of that pilot-type project, which then turned into, where do we put the investment? Do we go out and do we buy a vendor-based solution, such as something from HP or Oracle or something like that? Do we invest in-memory processing technology, or do we turn to the cloud? Now, there's many different ways to turn to the cloud. You have companies out there that are offering kind of big data, all-inclusive type services where they provide the platform and you just have to deal with initially loading the data up and then creating your own algorithms. There are also companies out there that just basically host a Hadoop cluster. You can see many of the large hosts out there are getting involved in that, where you just build your own Hadoop platform on their infrastructure. And then, of course, there's even the hybrid approach where you have some data out in the cloud and you have some of it local, and you apply your algorithms to both sources and then process it in memory. So there are a lot of different ways to get started. It all comes down to kind of that whole velocity idea. How fast do you want to get started, and how quickly do you need to get results out of the system?
Right.
So I turn it back to you.
Yep. Well, thank you, Frank, and I agree with that, in that deployment options shouldn't be limiting. We've always believed in a cloud and service approach, and cloud doesn't always have to be a public cloud approach. It can be a private or a hybrid cloud option, as you mentioned. But the deployment option shouldn't really be a limiting factor. I think an elastic cloud-based service approach is really what I think is most highly recommended. So the value of it can purely be around the insights you get out of it, and less about management and maintenance of such a solution. Now, in parting, perhaps just a bit of your take on the book. So you've written a best-selling book. What was the inspiration behind, in a quick minute or so, and what would you say are the key takeaways from readers of the book?
Well, the inspiration came from the fact that I was, covering some big data topics for a couple of major technology publications. And I kind of came across the idea that understanding what big data is all about was relatively murky, especially for those that are decision makers, the C-level executives. That, I found that people that understood big data and what it meant had a great deal of trouble explaining to C-level executives, the folks that hold the purse strings, what big data can truly deliver. So the only way to get kind of started on a big data project is to get the blessing of C-level executives, whether it's the CFO, CIO, or even the CEO. So I decided to come up with a text that described the business value of big data, delved into the ideologies, and what someone should demand out of a big data solution to provide both those pitching big data and those that are looking to adopt it with enough background to be able to make intelligent decisions. And that's what drove me to do this particular book, because what I'd seen out on the market, everything dealt with it from a purely technical aspect, how to build a Hadoop cluster, or how to mine data, or, how to do map reduce, how to do things like that. And that wasn't where the issue was. Sure, people need to learn how to do that, but to get to the point to do that, you have to have sign-off on a project. So I took it from that approach to help educate people to be able to, ask their bosses to fund big data projects, and also for their bosses to understand what big data is all about.
Very good. Well, I thank you, Frank, for your time, sharing the insights, as well as would like to invite you later in the year for a part 2 of this program, which we will advertise very soon. And to the audience that signed up and attended today, thank you very much. You can go to cetas.net for a free trial and for your analytics. And we'd also like to advertise our next webinar coming up next month, which will be around the healthcare vertical and how big data analytics features from a BI standpoint in that vertical. So with that, Frank, once again, thank you so much for your insights and your participation. And,
thank you.
And thanks to all of the audience as well. Thank you all. See you next month.